So today we are going to go over the practice exam. And let's see, so canvas.temple.edu. Just a couple of administrative notes that are very much related to the exam before we start. So first and foremost, for students, the exam, a couple of your labs do take place on Rosh Hashanah. If you are Jewish and you are going to be missing school because of Rosh Hashanah and thus aren't going to take the exam, please just let me know and we can arrange to take it on another date. If you are, so simply put, in general, if you have religious beliefs that are important to you, then they are important to me. And if you have something going on, such as a holiday, a fast, or something that would otherwise interfere with getting an accurate assessment or prevent you from coming to an assessment, please let me know. For instance, I don't want to necessarily, for instance, I've had this in previous semesters. If you're taking an exam at 2 a.m. and you're in the middle of a fast, that's going to be not necessarily the most accurate assessments of your abilities, right? If you're taking at 2 p.m. in the afternoon. So we can work around that. But like I said, your religious, if you've got religious beliefs important to you, then they're important to me. So same goes if you have a lack of religious beliefs, that's important to me too. So please just let me know if there's something we need to arrange around. Second, if you are sick, please please don't come to the exam, right? If you're sick, don't come to the exam. Instead, send me an email. The way this works, if you have to miss the exam for any reason, then basically you need to make up the exam within a week. You can make it up by just sending me an email and CCing your TA. Basically, you'll just simply coordinate a time for the TA to proctor the exam to you. Make sense? Right? A doctor's note would be preferred, but we really only need it in case there's something that's going to prevent you from doing it within that week time frame, such as you are hospitalized. I just don't, again, think I'll get an accurate assessment of your abilities if you take the exam while sick. Also, it's just kind of rude to spread illness to your fellow students. So again, and I just ask, please don't abuse, this. If you're not sick, come to the exam. I understand you may not be prepared, but you do need to come to the exam. If you have a DRS accommodation, please let me know in advance, and schedule the DRS. I'll send them the exams. If your DRS accommodations mean that, you're having trouble scheduling that for some reason, to take it at the same time, that's fine. I'm very flexible as to when you take it, as long as you're taking it within the appropriate time frame, like on the same day or maybe the day before or the day after. Again, scheduling with DRS can sometimes be tricky. That might mean a student needs a private room or something to avoid distractions, okay? Or they might need to take breaks for medical reasons, okay? So those are different reasons that a student might need a schedule for this. There's lots of other reasons, but those are some of the most understandable for people. Okay, so first and foremost, question that I surprisingly have not gotten asked. You are allowed a cheat sheet on this exam.
Oh, really?
Yeah,
Really?
front and back, one page.
Wow.
What? I don't want your cheat sheet. You can keep it, so I don't care.
Where is it?
I don't care. I don't care. If you decide to make your cheat sheet microflation, you need a microscope to read it, then that's fine. So why? The question is why. The answer is that part of in terms of programming, okay, a programmer is almost never going to be without a search engine looking up stuff, right? In real actual kind of writing code on the job stuff. You're always going to have a giant pile of knowledge to you. That being said, right, part of what you need to know is what do you need to be able to reference? And that's what the cheat sheet is going to help you help represent. It's going to represent, do you know how to prepare? Do you know what kind of things you need to know? Did you have another question? I said a sheet of paper. I said a sheet of paper. Don't ask for additional rules if you don't want additional clarification.
Yes. So, given that we are being given the ability to bring a cheat sheet, I think there won't be a practice exam or anything. It'll just be like, bring in any information you want, but like this is just like the range of chapters.
You can copy. You can put anything you want on the cheat sheet, except for, say, like copies of the actual exam that I've hand out, if that makes sense.
Well, I'm saying that makes sense. I'm saying, is there maybe you said this already, what's the range of chapters for the exam?
It goes through 4 loops. I think so. I think that would go through 7, chapter 7.
Up to chapter 7?
Yeah. All right. All right, so let's take a look at the practice exam. So the first question on the practice exam is, what is computer science? Wait a second, no, this is the actual exam. That's the first question on the actual exam is, what is computer science? Be sure to know that. Refer back to the first lecture. The second question on the actual exam is, the word algorithm comes from what? Refer back to the first lecture for that. That's a reminder to go back to that first lecture and just look at some of those facts I asked. They do correspond with that first page. Okay. But in all seriousness, I will basically have this exam right here so that I can compare notes and kind of tell you the difference that you can expect between the exam and practice exam. Part, especially with you being fall freshmen and also being in a new class, is you don't really know what to expect. That adds an additional stress besides trying to know what you need to know. So I'm just going to try to remove at least as much uncertainty about that as possible. Okay? Okay, so you may have noticed something odd on the first page of the exam, that there's 105 points on it. Okay, so what I've done is I've baked in some extra credit into the exams. There's 100 points on your exam is out of 100, but there's 105 points. So you could technically get 105 out of 100. It also means you could miss 5 points and still get a quote-unquote perfect score. It also means you could miss 15 points and still get a raw A, okay? So that's just kind of also me being indecisive about removing some problems, but hey, it works, but, you know, it works to your advantage. I don't try to make anything harder. On the back of that first page, I actually do include some useful notes. On the exam, I will have basically some things that if you forgot to bring a cheat sheet, some of the things I might have wanted to jot down on that cheat sheet, okay? Such as such as examples of how some slices work, okay? They won't necessarily be the most useful things, but they will help jog your memory if you forgot your cheat sheet or something, okay? But important, okay, is the points, the amount of space on the exam, okay? The amount of space that you have on the exam for a problem does not correspond to the difficulty of the problem. Okay? If I give you a lot of space, it's because I think that maybe drawing can be messy sometimes. If the difficulty of a problem corresponds to the number of points that problem is worth. Okay? Okay, so the other thing is that sometimes I think I've done my best to remove anything that has ambiguity in it, but as much as there is ambiguity in it, if there's any ambiguity and you need to clarify an answer, even if it's a multiple choice answer, you're allowed to write whatever justification you've had. I've had it maybe twice over 10 years where a student has argued that their wrong multiple choice answer was actually correct and they got credit for it because of the justification provided. You are allowed to ask for clarification on the questions. You are allowed to ask to make sure, in case something is ambiguous, okay? So we occasionally do make mistakes. Or by we, I mean I. I occasionally make mistakes in writing the exam on it. Once again, remember that the math that I have on the exams is never meant to be complicated. You should not need a calculator. You aren't allowed to use one because those are programmable, and you could totally run Python on some models. But you shouldn't need a calculator to do the math. It's supposed to be fairly simple math. Okay. And then the last thing is that exceptional answers, two things. Exceptional answers, I have, I might give extra credit to if they're like extremely clever or extremely something I've never really seen before. And finally, this is just general test taking knowledge. Never leave a question blank, even if you don't know the answer. I can't give partial credit for blanks. That being said, what I mean by that is don't write just random thing from your cheat sheet that kind of looks maybe that it might apply. I'll recognize where it's from and say, no, you just copied something in that you didn't, that's not relevant. Instead, what you want to do is that, if it's like, okay, I need to loop through everything, for this problem, I need to loop through every letter, okay, but then I forget what I need to do for the next part, then just write the part where you loop through every letter. I can give partial credit for that, right? Or write a comment saying, then I do this through magic, and then I continue on with the rest of the problem, and then you continue on with the rest of the problem, leaving that magic step as something that you obviously forgot, but I can give credit for the stuff around it. Or maybe I can give a point for just recognizing, oh, the student recognizes what this is, they just forgot how to do a slice or something, right? Make sense? So that kind of thing. Okay. So, basic concepts in history. True or false? Computer science is the study of computers. False. What was a good answer? What did I say was not wrong? Yeah, the study of algorithms. All right, true or false? Alan Turing is often considered to be the first programmer.
That's false.
Yep, false. Who's generally considered to be the first programmer? Ada Lovelace. Yeah, Ada Lovelace. Or Ada Byron, or, those English nobles, they have plenty of names to just pass around. Okay, and that brings down, and that answers the third question, who was Ada Lovelace and why is she an important figure? Okay. And one last thing, does anybody remember where the word algorithm comes from? Yes? Yeah, the Persian mathematician Muhammad ibn Musa al-Khwarizmi. I probably butchered his name, but his Latinized name was Al-Ghamidi. So, now on the exam, these won't be true false. I will have these structured as multiple choice because that's easy to grade. Yes.
Are you sure the inventor of the algorithm wasn't Al Gore, the creator of the internet?
Hold on a second. I really should have put that in as a wrong answer on the exam. Actually, full disclosure, for that one I asked ChatGPT for some wrong answers and it came up with some great stuff. So for these expressions. Now here on the practice exam you have 10 questions each worth a point. On the actual exam you have 5 questions each worth 2 points, right? Because it makes sense to make you have less on the actual exam. Furthermore, on the actual exam, these are multiple choice, right? Because that makes grading a lot quicker. I've got a lot of students, we need to grade quickly. And of course, the way this works is that there will be 4 things for multiple choice. One of them will be right, 2 of them will be wrong answer, and 1 of them will be error. It's never error. That's a useless answer. Okay. So anyway, no, it's never error. Okay. Anyway, so let's see what these are. So for this one, a lot of these are just trying to remember order of operations. So here, you need to go left to right. Multiplication and division, as always, happens left to right. So it would be 2 times, so this is what I mean by the math is always kind of easy. 2 times 3 is 6. What's 6 divided by 6 in terms of integers? It's 1. And then 1 times 100 is 100, right? That's what I mean by the math being easy. Okay, yes?
With PEMDAS, modulus and floor division occupy the same spot as a normal in the order of operation.
Yep, modulo is the same. Modulo is considered division. right? Just remember, modulo is just division. It just gives me a different answer, right? That's the best way to think about it, right? So in this case, right, that's why also I gave you these problems, because you can check them. Okay, here you have 1 mod 2 plus 3 mod 2. Okay, here I'm just trying to remind you, okay, modulo is division. It goes before the addition. So 1 mod 2 is just a fancy way of writing 1, because 1 divided by 2, the remainder is 1. 3 divided by 2, the remainder is 1. So 1 plus 1 is 2, right? Again, this is what I mean that it's fairly easy. Negative 1 plus negative 10.5. Oh, right. I'm reminding you that negative number and floating points exist. Okay, what happens when we add an integer, when any kind of integer interacts with a float? We convert. So it becomes negative 1.0 minus negative 10.5. So in this case, we're adding negatives, so it becomes negative 11.5, right? So again, the math, I'm trying to be very straightforward about it. I think this one maybe is the most, I mean, again, you'll see. 4 plus 5 minus 3 times 2, order of operations. 3 times 2 is 6, so it's 4 plus 5 minus 6, right? Because the multiplication happens first. 4 plus 5 minus 6, that is 9 minus 6, which is 3. Okay? Okay? Right? Math is never as complicated as it appears. We have a 0 times, I don't care what that is, right? 0 times anything is 0. Doesn't even matter that this is in parentheses. It's multiplied by 0, so the point is moot, right? It's just 0. 0 minus negative 1, so this would be what? Sorry, not minus negative 1, minus 1.0, yes.
Negative 1.0.
Yep, it's negative 1.0, because it's a 0 minus something, okay? 2 times 4 minus 20. I don't know even why I have this one in. Well, just to remind you, I guess, just to give you good mental practice, negative numbers, I guess. 8 minus 20, right? So that should be negative 12. Okay, this one's a bit scary because of that, again, that double divide again, right? So 7 double divide 3, right? 7 divided by 3 is 2 point something, right? Well, fortunately, with the divide, we don't care about that point something, right? We just want the quotient. So it's 2 plus 2 times 3, which is 6. So it's 2 plus 6, which is 8. 4 mod 2 times 3. 4 mod 2, 4, when we divide by 2, has a remainder of 0. So 4 mod 2 is 0 times anything is 0. So that answer is 0. By the way, a bit of advice for your physics exams, your math exams. The answer on physics and math problems, because, professors are lazy. I say this being a professor. Those answers are often either 1, 1/2, 0, or negative 1/2, or negative 1. It's just because we need an easy number to check. I'm giving away the secrets here. All right, so we've got a small number divided by a ginormous number. Yes?
Is that 0?
That is also 0, right? Small number divide enormous number means that there's only a remainder. There is no, 0 would be the quotient. Everything is just stuffed in the remainder. And this is just to remind you of exponentiation, right? Exponentiation, okay, is, so here we have 10 star 2, which means 10 to the second power. So it's 100. Then multiply that by 2, because exponents first, then multiplication. So this becomes a lot easier mentally for you if you replace this with the caret symbol, right? 10, 2 times 2. All right. So now one more question that I didn't put on the practice exam, but I might as well ask. If we had something like, let me pull up IDLE actually to type it out. Right? Now I said there's no errors on the exam, so give me a second to just simply type out something with an error. Okay, so if I asked you this on the exam, 4 plus, okay, 4 plus 5, what does that give? Gives error, right? 4 plus 5 is an error. You can't add strings in a number. So what if I gave you, let's go with 2 plus str2. Okay? What would that be? It would be 2, 2, right? It'll be 2, 2. On the exam, if something like this happens, hint, hint, there will be quotes around it, you know. So just remember you need that str to add. Okay. Now, also on the exam, I'm going to skip forward before I go to this. I'm going to go in the order of the exam, is 3 of these problems. Okay? 3 of these problems. Okay? And these are significantly harder than what I have on the exam. Okay? These true-false evaluations, right? Okay? So hopefully you've had the chance to go through the chapters for those. If not, these are not that difficult. These are Boolean expressions. Okay? Simply saying what's true and false. And so we've got 3 keywords. We've got and, are both sides true? Or, is one side true? Or both sides. And then we have not, which says, can I have the opposite, please? Right? So for instance, with A, it's true or something. It doesn't matter what's on the other side of the or. One side was true, so the whole thing was true. Okay, not false. That's also true. So now we have 4 less than 2. That gives me false. Not false is what? True. So that left side is true. Just remember that as best we can. And 3 divided by 10 is true. So true and true is true. So we've got true, true, true. Okay, this one's a fun one. And I put this one specifically because I wanted you to look this one up if you were taking the practice exam and wanted you to look it up afterwards. Okay, 32 divided by 8, which will give us 4, is equal to 32.0 single divided by 8. So in other words, we've got 4 integer. It's asking is 4 integer equal to 4 floating point. And we can plug that into this. But the rule in general is if we've got a float and an integer interacting, the integer always converts to a float. And that's true for these equality operators. So this answer is also true. And then this was what I mean, like I've got stuff that's way more difficult on the practice exam than the actual exam. This one's just mean, I think. True or 3 divided by, well, again, it's true or something. So this inner parentheses is true. Okay? So again, I'm working from inner parentheses to outside of them. Then we've got false or true. False or true, one side is true, so the whole thing is true. So we've got true, and we had true, but then it's knotted, which means it's false. So true and false becomes false, but then we have another knot on the outside. So that false turns into true. So that's also true. So the answer to all 5 of these were true. It's also to let you know a hint. Like I've mentioned, I like things being easy to grade. I've done this on an exam before. I switch it up every year, whether or not I'm doing something like this. So don't be surprised. So don't be alarmed if all the answers are the same, and don't be alarmed if all the answers aren't the same. Yes. No, I've got bubbles here. Like it's bubbling. I don't need the Scantron. These are quick enough, and there's not enough points to justify a Scantron. Right. So let's see. Now I'm just going to go back here for this one. On the exam, let's see. This one is not a multiple choice. Let's go ahead and... Ooh, I've got a clever idea. No. Come on. No. What are you doing? I want a screenshot. There we go. Okay. I had a clever idea. Ha ha! I feel so smart sometimes, right? I put this on the whiteboard. Okay, so we've got this problem, and now I can draw on it. Great. So a lot of times, what I suggest for problems where we're trying to figure out what values of stuff are, okay, is I recommend writing on the exam to keep track rather than trying to keep it in your head. I was doing everything in my head because I could, because I've went over this exam a ton of times. Like I knew in advance all the answers were true, so it made it made going in reverse engineering that fairly easy, right? And so so don't think you have to do these all, or I expect you to do them all in your head. If you try to do that, I'm going to be mildly annoyed because that's dangerous. It's very easy to make mistakes. So over here, I'll do things like this. X is equal to 7, y is equal to 8, z is equal to negative 5. So over here, I'm going to keep track of these values. X, y, and then z, right? 7, 8, and then negative 5. And the question is, what are the values of these after I do all these operations? So it says x is equal to x plus 1, right? X is equal to x plus 1. So that means we are asking if that's 7. So we say x is equal to 7 plus 1. Then we take what's on the right and store it on the left. That just happens to be x, so x is now 8. Y is equal to x plus y plus z. So x is equal to 8 because x is now 8. Y is also 8. 8 plus 8 is 16, plus negative 5, which is just a fancy, overcomplicated way of writing minus 5. So 8 plus 8 minus 5, 16 minus 5, which means 11. So this becomes 11. We take 11, we store it in y. Now this one, z plus equals 1, is again one of those things that I would find exceptionally mean on an exam because that's almost a trick question because I'm asking to increment it. And a lot of students do make the mistake of saying, okay, I'm incrementing this value by 1, so it's negative 6. And that's just kind of moving fast on an exam. This is actually a completely understandable human error, completely understandable. And why I put it on the practice exam, right? Because it's kind of unfair in some ways if you're nervous. But remember, this is just simply saying z is equal to z plus 1. Z is equal to negative 5. Negative 5 plus 1 would be negative 4. So it's equal to, right, negative 4. Okay. So let's see. Okay. So on this exam, once again, on the actual exam for the slice problems, that will be worth 8 points on the exam. There will be 4 problems. All of them are multiple choice. Okay? All of them are multiple choice. Okay? And again, I will do my best to copy these over. Okay. What do each of these evaluate to in Python? Okay. Whoops. No. Do I need to? Got it. Okay. And paste. So consider the following. A is equal to an apple a day, and B is equal to Ansinded eine Schmiers Swangby, whatever that is. It's gibberish. It's pseudo-gibberish, I promise. Okay. So, and actually this follows very similar to what we would see on the exam. So what is A3? So this isn't, yes. Yep, this isn't so this one is not a slice operation. This one is just getting an index operation. It's kind of, again, it's almost like I'm progressively getting more difficult on these. Now for these questions, I highly, highly recommend using your pencil to your advantage. What do I mean? I mean doing something like this, okay, where you put 0. Okay, let me see if I can't can I lower the thickness of this pen? Yes, I can. It's super thick right now. Okay, so I recommend doing something like this. 0, 1, 2, 3, 4. Sorry, I'm doing this with a mouse, and my handwriting sucks to begin with. But you get the idea. I'm writing the index above each of the, I'm writing the index above each of these, and I happen to put everything in a monospace font, so it's all going to line up. So this will make things a lot easier. 7, 8, 9, 10. So then I start using 0 again, just so that I don't take up as much space. 2, 3, right? So let's go ahead. A3, right? 3, that would be A. 3, do you have to put quotation marks around it? I'm not going to care. Also, it's multiple choice, and I'm not going to do a trick question like that. You know, it's just that's like pedantic levels of things, because if it clearly communicates the meaning, if the answers completely communicate the meaning of it, then it's not worth being pedantic over. Okay. A is 3 through 8. Okay, so that means we start at index 3, which is A, and go up to but don't include index 8, which is the space over here, right? So that would be apple. Now over here we're getting into some, let's call it fun. Okay, first we have B is -2. Remember, we in Python can use negative indices, right? So remember, -1 is the last character, -2 is the second to last. Okay? So that's just kind of remind you that negative things exist. B is equal to -2, so -2 on B is this guy, B. So B, so I'm going to write it down so that I don't forget it. And then A3, we've already established that that is A. Okay? And then A, beginning, and so this is a slice, okay? This says from 1 to the stopping point. When we leave it blank like that, that means to the stopping point for a slice. And then -1 means, normally this is blank, right? And blank would mean going up. -1 here as the step operator, right? It's start, stop, step, just like a range. If it's -1, it means we're going to go, our step is -1, meaning we go backwards. So here it's saying on A, start at N and go through the N, through the stopping point. So it'd be NA times 2. So it's B, A, NA, NA, which makes sense because the previous answer was apple, right? So it being banana seems like it's a fairly safe bet. And it is. If you have trouble understanding this, I would copy this into a terminal and then, go through each individual point. The B, -2, the A3, and then basically just look at each individual thing and play around with it. Now this one, B from 1 to the end, to the stopping point, which is the end of it this time, going up by 2s. So index 1, right? So index 1 is this guy over here, H. And then it says we want to go up by 2s, which means we want index 3, index 5, index 7. This is just a fancy way of saying every other thing, right? So let's just go ahead and underline every other index, all the odd indexes. H, I, D, D, E, N, space, M, E, S, S, A, G, E, which is hidden message. So the last answer is hidden message. I know. Silly, I know, but I feel like I like doing things like this. They're effective teaching tools. All right. Let's go back to the practice exam now and see what is next. All right. So complete the function. The function takes in a string and prints the string in reverse. So once again, when we are dealing with, I think so when I have you writing code on the exam, okay, let me see, so I'm going to go through the exam right now and ask you, and I'm going to just nail down where I'm asking you to write code. So let's see, question 10 is write a for loop that prints out something, right? Okay, so I'm just asking you to write a for loop that prints out something. Let's see, nope. Oh, okay, question 14. Here's some code. Please fill in the blanks where the blanks are in arguments. Right? And it's turtle, so I'm asking you to put in the right things in the turtle so it draws correctly. Okay, but the blanks are already there, you know. And then that's question 14. Question 15 is here's a bunch of code that draws one picture. Here, add in code in the empty space to make it draw the second picture. It's it's not as scary as that seems, because again, the shapes I'm dealing with here are, you know, squares and diagonal lines at most on another problem. So that's it. That's three places where I ask you to write code on the exam. Most of this is actually code reading and evaluating, not code writing. Why? Because that's where I feel like it's comfortable to test you, and it's a good place to test you. Okay. So complete the function. The function takes in a string argument text and prints the string in reverse. So there's a lot of ways to do this. You could do it with slices, or you could do it with accumulators, right? There's a lot of ways to do this. You could do it with range and just printing out stuff slowly. There's a bunch of ways. As long as it works, I'm happy, right? If it works, so in the sense that like it's a valid idea. If you make a minor syntactical error, whatever, that's maybe a point off on minor syntactical stuff. If you're off by one, that's a couple points off, depending on how much the problem is, right? I try to grade my problems, okay, like they're the entire test. And what do I mean by that? Well, if I think it's an A answer but not fully correct and it's worth 5 points, then that's 4.5 points, right? I do try to give my TAs a rubric, by the way, so that there is no ambiguity. A bit more transparency about the way the grading works. I get on, because we have so many exams, what I'll be doing is that the TAs will have the exam and they'll grade them. What we do is that we get onto Zoom, I go over the rubric with them, they stay on Zoom for a while, we all stay on Zoom for a while while I basically go over any questions that they have on individual student answers, and eventually they'll get into the flow of things. I also, and this is the mean part, and I'm sorry about this, but it is the most effective way to deal with it. So please, before you are horrified, listen to my full explanation. I tell them, when in doubt, take away more points than awarding more points. Why? Because I can always give the points back if they were too mean. That's it. I can't take points away from you, because that additional points away from you after the exam, because that's unfair. But I can always give you more points back, and I do. I do if it's an unfair case. You can ask tons of students. I think the most points I've given back was 20, but that was an addition error. So, so add up your points, please. You know, maybe it was 10, but it was an addition error, and it was significant. You know, we try our best. Human error still happens, right? Okay, that can be a reason why that happens. Again, if the TAs seem like they took an inappropriate amount of points off, yeah, it's probably the case. Some of them this is their first time grading stuff, you know? I try to make, though, sure that we are being consistent as possible across sections, which is why I give these rubrics out, okay? If I feel that it doesn't abide by the rubrics, then that's how it works. Other years, what I've done, and it really depends. Other years, what I do is I sometimes I stuff off all in a room together, but it also just depends on how many TAs we have. We have a lot of TAs, and the more people you have, the more difficult it is to find a single time that everybody can get together on campus. Okay, so let's talk about the various answers that you can do for this one. With print reverse, what you can do is you can do a few different ways of solving this. Okay, so way number one to print out this in def reverse, right, text. Okay. Way number one. Okay. So let's go with kind of the just printing. All I know how to do is print. For letter in. So there's a couple different ways. So for letter. Let's go with I in range text. Sorry, not text, but 0 to length of text, right? Go up through, so this one goes through all the indexes, right? Print text I. This is incorrect, by the way, but I'm going to go move into a correct answer. Okay? Print out text, and then you're like, okay, wait, this will print out on separate lines, so I'll do end is equal to, right, so that they'll stay on the same line. Now this prints it out, like if I give you apple, this will print out apple rather than ELPA, okay? So to print it out in reverse, what should we do? Well, we can go through the indexes in reverse, like this. Length of text, -1 is the first index. The last index will be, we want to go down to, but not include the last index, and go to 0. Sorry, and go down. This is one way to do it. It's also kind of like the worst looking way, right? Looks terrible, but that's fine. If you do it this way, it's the correct answer. What's another way we could do it? Another way is we could do something, we can use the accumulator. Output is equal to for in range, sorry, not for in range, for letter in text, right? Output, this is how I would add things to output. Output is equal to output plus letter, right? Output plus letter, okay? And so what I'll do is I'll add, and so this would just simply go, if it was Apple, it would go A, then AP, then APP, then APPLE, and then, APPL, and then APPLE. Instead, maybe what we want to do is that we want to do the reverse. And with a little thought, you might figure out this. Letter plus output. What does that do? Well, it adds what we have to the beginning of our accumulator. How does that work? Well, first thing we do is we add A in. Then we add P in front of that, so it becomes PA. Then we add another P in front of that. So P plus PA. Then we add an L in front of that. And then we add an E in front of that. Okay? You can also do the same kind of thing over here with the other one, and then you print the output, of course. Right? And here are what I call the I paid attention in class, or I paid attention to the textbook answers. Where I printed, which that is the shorthand for a slice, which goes from the start to the finish in reverse. This is the shorthand for any list. This over here is the shorthand for any list and any string to be done in reverse. In fact, did I have that on? Did I have that on the practice exam? Maybe. Another one, though, is print, I believe, reversed text. That's built into Python. I haven't taught it to you. What if you use it on the exam? Full credit. If it exists in Python, if it's built into Python, if it's a Python library and you decide to import it because you know it, fair game. If you, on an exam where your resources are limited, if you just know stuff off the top of your head because you studied your butt off, okay, then I am going to reward that, okay? So there's, again, I don't care necessarily on exams what the technique you use to get to a correct answer is, okay? We care about the efficiency of answers in future classes. Right now, it's, does it work? And then we can talk about efficiency after it works by presenting alternate answers to you. Okay. Okay. So this question and the next one are pretty much exactly the same on the exam. The only difference is the shape that we draw here with Ziggy. Okay? So let's see. Cool. Okay. So with draw Ziggy, let's go ahead and, so there's plenty of this on the exam where I say, and on the practice exam where I say, hey, can you please draw the output? Okay, and, sorry, they updated this with a nice hotkey for dragging stuff. So draw the output of the program below. Draw a Ziggy. So you don't have to be, you don't have to necessarily draw the turtle, by the way. You don't have to like make a little turtle or a triangle or whatever. Well, of course, what I care about is like, what does the turtle draw? So let's go through this. So 4-step in range length, where here length is 5. Makes sense? We're passing in 5. So 4-step in range length. So first off, Bob is facing this way, and Bob dot right 45. That makes him turn. Like I said, I'm only going to really give you right corner turns and diagonal turns. So essentially the 8 compass directions. Okay, 45. Turn 45. So now we are pointing this way, right 45. Okay, so we did that. Then we say go forward 10. Okay, was that a perfect 45-degree angle? No. Of course not. It's not the point, though. Okay, forward left. Sorry. So we did forward. Now we do bob dot left 90. That means we are facing this way right now. We want to be facing now a 90-degree turn to the left from that. So this is this 45-degree turn to that direction, and a 90-degree turn, right? A right angle. So now we've done that turn. Forward 10. So we go up as much as we went down. Right? Nice and symmetric. We went up as much as we went down. And then bob dot right 45. So we were up here, right? And we want to turn 45 degrees to the right, which means that we need to go facing here. So we're facing front again. Very convenient that that the way I've set this up is going to always make you face the same way that when you started. Okay? So one iteration did a little triangle, like a little kind of V actually. So then we go through this again. Turn right 45, move forward 10, turn left 90 degrees to face, the other diagonal direction, and then go up. And then turn right 45 so we're facing this direction. And we just proceed to do this 5 times. Now, this is not what the turtle draws, right? The turtle does a much cleaner job of it, right? Mine's all jagged, it's not lined up. I see it on your exam, and I put a big check mark next to it, okay? Don't worry, you don't need a ruler or anything. Basically, if you get the shape right, that's what I care about, okay? If the generalized shape is all I care about, right? If you did something like this, no, because it looks like you went squibbling that way and back that way. I have no idea what you did, right? If you do, no, because it looks like the thing's getting bigger and bigger, right? But if I see something like along the lines of, okay, yeah, that's fine, right? That's what I'm looking for. Okay, so it just draws this sawtooth that I say. Okay. So now I suppose I change the program to the following code. What makes this change significant? In other words, what control or power does the programmer gain by, you're jumping at the bit here. Did you want to answer that one?
I would say the size change instead of length.
So, well, not instead of, right? We have both bob, length, and size, and they're both in there. So, did anybody draw this out and try playing with it? What happened? Yeah, what changed from the top to the bottom? If you, I'm not going to, we only have half an hour left, so I'm going to go quickly. Instead of having 10, we have size here, right? That's what we changed. So, a partial credit answer would be something like, oh, instead of moving forward 10, he moves forward size instead. That's because that doesn't tell me what it does. It tells me what the change you made was, but it tells me what I have to gain from this. What I have to gain from this is that I can make bigger shapes now, right? I can make bigger sawtooths. Okay, I can make I can go from making something that looks like this, and you can test it out for yourself, to something that looks like this. Okay, the shape just kind of gets taller. So if you talk about how this affects the size, that's the kind of answer I'm looking for, right? The shape gets taller. Okay. Draw the result of the turtle program below. You can use a dot to represent a stamp, right? Now, if you remember, so you may not have seen this much until now, but the stamp is when basically it's the other way of drawing things, right? Typically, the turtle drags a pen behind them. Here, with the stamp, the turtle's going to do that little belly flop and basically make a stamp of himself. Okay? So, turtle, Bob is equal to turtle.turtle, turtle.penup. That is the important bit here. Let's go ahead and drag this over to something I can actually draw on. I used to do this on Zoom, and then I'd have the annotations. But the issue is Zoom, I have to wait for for everything to render on Zoom for the recording, whereas using OBS, it's like already rendering in a format I can open up even if as it's recording. So, okay, so here, pen up, that's the big one. What does pen up do? That means that if the turtle moves, this way, instead the turtle's, it's not going to leave a line. Instead, the turtle will just, okay, why isn't it not? It should undo now. You should undo. There we go. Okay. It should, basically, if the turtle moves from here to here, it's not going to draw anything intermediate. Okay, that is weird that we are not, come on, Control-C is a thing. Sorry, Control-V is a thing. Okay. Here we go. Okay. Okay. 4-row in range 5. So this one is a nested for loop. So there will be one other question like this on the exam where you do have a nested for loop. And just to be clear here, I don't do, I try my best to avoid doing something that's a trick question. So when I say row here, that implies that this for loop is a row. This outer for loop is a row. And then when I say something like this, when I say for dot in range row plus 1, I mean, you should be able to go, he's going to do for each dot in this row. Okay? So that means something. I try to make my variables mean something because that's good practice that you should follow too. Okay? So, Bob.penup. 4 row for row in range 5. Okay, so range 5 means the value 0, 1, 2, 3, 4. So right now we are at row is equal to 1. Sorry, row is equal to 0. 4 dot in range 0 plus 1. So this becomes 1, right? That would be 1 right now. Bob dot stamp, so he makes a belly flop. Bob dot move forward 50, and I'm just going to use the X over here to represent the current position of Bob, you know. So this loop operates one time because it's zero, the range is 0 plus 1, right? When you see range however many, and that's how many times this loop is going to run, right? So now we do this bit now that Bob is over here. Bob dot right 90 degrees, so now Bob's facing this way. Bob dot forward, so now he's here. And now Bob dot right 90 degrees, so we turned down first. Now we do another 90-degree turn to the right, which would be to face. So we were facing. So we've turned a total of 180 degrees, right? Right. And now forward 50 times row plus 1. 0 plus 1, that's 1. So he moves forward 50 total, right? Now, how much is 50? I don't know. It just happens to be, but 50 is the unit that I use for forward, right? That's what it matters. I always try to make sure that the unit I tell things to move is kind of the same to make it easy, or to make it doable, I should say. Okay? And then over here we have right 180. So we turned from here we turned 90 degrees to go this way, another 90 degrees to do this way, and then another 180, which means now, so 90 plus 180, all in the same direction, that's 360. We're facing in the same direction. Okay, so now the turtle is right here now. Okay, so it's right below the original position. Now, row is 1. 4 dot in range, 1 plus 1, that's 2. Do the following. Stamp, forward, stamp, and do that twice. So stamp forward, we did that once. Stamp forward, we do that twice. So now Bob is here, and then we do the same thing. Turn to the right, move forward, brings us here. Turn to the right, move forward 50 times 2, which is 100. Now this is the part that might get you, but don't worry. We moved forward in this direction 100 to do this row. And now you say, all I've done is with this, I've turned around, right? I've turned around now, and now I'm asking you to move back the same amount that you moved forward. So now you're here. And then turn around so we're ready to do the next line. In the end, the answer comes down to this, right? Stamp forward, stamp forward, stamp forward. We're now here. Turn around, move down, then move as much as you moved here. Then stamp forward, stamp forward, stamp forward, stamp forward. And then the last line is this. How would I grade this? If you came up with this, partial credit. This was 10 points, so maybe 3 points off on that if you missed the last line. Okay? If you did this, if your answer was this, something like, you drew a square, did the exact same thing, that's half credit, I would say. Because you got half of it wrong. Yet you did twice as much. It seems, okay. You forgot the top, probably a bit more forgiving than forgetting the bottom. Regardless, the point being is that I will have for these stamp questions, I do have a very large rubric. If I were to tell you practice anything, it would be practicing this because there is another 10-point question on the exam that is very similar to this one. Okay. Okay. Draw a square, right? So here we're getting into stuff that we, okay, I'm just trying to make sure, how much of this exam do I still have to do? Okay, enough, but not too much. I've got the important bits down. So on the exam, you might do something like this, but like it will be, I'll give you most of the code and ask you to fill in the blanks. Okay, so here, complete a function below, so the turtle passes an argument, draw a square. You should have done this one before, right? What this one is to draw a square. Okay, so over here, what I'm going to do is draw square, Bob. Also, don't worry on the exam. You don't have to import turtle on the exam. You can assume that turtle's imported. So don't worry about, so if you include it, whatever. If you forget to include it, it's not what I'm trying to test, right? Program wouldn't run anyway if you, on the real thing, and assume, it's one of those things that like you'd fix on a real exam, right? On a real, program, instantly. So, anyway, draw Bob and then side. So we've done this before. We would do for in range, and then we want to do it 4 times. Move, and if we want to do a square where each side is the length of that, right? Then we do Bob dot forward side length, Bob dot right, or however many. Yeah, let's go with right, 90 degrees. Okay. Call this, I'm going to save it for a minute. Exam. Pract. Okay. Then Bob is equal to, you don't need to do this part because when I say because all I need is the definition there. Bob dot forward. Set Bob dot draw square Bob 100, right? Just make sure it works. Cool. We've drawn a square. Now the next question, which I definitely think might look the most challenging on the exam, is using the draw square function. That's your hint to use something you wrote in the previous page. Write a turtle program that will draw the shape below. You may create more functions if you wish. This is just to organize stuff. Okay, so here, the picture, and I added something here. The turtle drew 4 squares. Why? Because if you wanted to be really, because somebody might get worried, right? When I tell it to use the draw square function, you're like, oh God, do I have to use a square to draw this, and then use a square to draw this, and then draw all these little squares, right? This is like one of those riddles, like how many squares are in the picture, right? That kind of thing. There's, this square, but there's also this square. You get what I'm saying? No, there's 4 squares. And once I tell you there's 4 squares, we can actually kind of better divide this. You have this square over here. Oh, actually, yeah, here we go. We have, we have this square, and then we have this second square, right? And then we have the third square. And then we have fourth square. Okay, why is the turtle in the middle like that? Well, maybe that's a hint or something. Well, I'm not going to worry about that later because if I need to move a turtle into the middle of a square manually, that's not too bad to do. I think I can figure that out. I'm trying to think as though I'm taking the exam. Okay, so what it looks like I need to do is I need to draw a square, and then I just need to draw 4 squares. So this is a for loop to call draw square 4 times. Okay, so let's start with that. Def draw problem. Okay, it's got to take in Bob. The the squares are all going to be the same size, so I'm not going to bother specifying how big that is. And then I need to do this 4 times. 4 in range 4, right? Because I need to draw 4 squares. I need to draw square, and let's call it Bob 100. But of course, I can't just do this because, right, not just this. There's something else. I need to do something else. Why? Because if I draw a square, then I'm just going to draw it again and again. I'm going to draw the same square again and again, right? So what do I need to do? In order to get them weird like this, let's see. Well, the next square starts over here. So if I want to do that in the for loop, what I need to do is I've got to move the square, the turtle, into the middle of the square. Oh, just like the end of the problem. Okay, so I've got to move it to the middle of the square. Okay, so how much is that to move it to the middle? Well, I have to move it to the middle. Well, middle's halfway. So that means I have to move it half the side length, I guess, across the top, and half the side length across the side, right? So what was that?
Oh, I wasn't sure whether or not I was suggesting a solution.
Sorry?
I was going to suggest a solution.
Oh, keep going. I'm going to keep going. So here what we want to do is we want to do side divided by 2. And we just got it. You might think, okay, can I do a 45-degree angle? On the exam, I'd be generous, but 45-degree angle, actually what you'd have to do is you'd have to remember some trigonometry, right? You know, that whole a squared plus b squared is equal to c squared bit. So instead, oh, wait, I don't remember that. Wait, which side would I go? And oh gosh, how do I do square roots? Nope, I'm just going to go, you know, city block it essentially. I'm going to do the horizontal and vertical. I'm not going to try to cut a corner. So I'll move down first, and then I'll move this way. So don't try to go diagonal. So Bob dot, so here what we wanted, so let's go ahead and say side is equal to 100, side, right, just to match it. Maybe we pass it in as it doesn't matter whether or not we pass it in. I said you could write your functions however. Bob dot right 90. Whoops, 90, not 80. That'll turn Bob to the south, and then tell Bob dot forward side divide by, 2, because that will move half the side, right? We want him to get halfway down so that he can get here. And then we need to move halfway across. Bob dot left to get him facing east again, 90. So in other words, undo what we just did. Or if you want to, you could do right, 360, 270. That works too. Forward, side, divide by 2. Boom. Okay, and that brings us to the center. So, and you think through that your bit, and you're like, yeah, that seems like the correct answer. Oh, right, well, yes it is, but I actually have to call it. If you had this, if you did just this on the exam, I'd be happy with it. If you forgot to call it, big whoop. Whoops, Bob is not defined. Right, I accidentally deleted that. Draw problem. Side. If you need extra practice on that one, not side. Wait, you're doing great here today, Andrew. Okay, here we go. No attribute forward. What am I doing wrong? I'm just trying to move too quickly. That's what I'm trying to do. Bob. And now you know why I don't do this on an exam, because boy, that time limit does do a number on a, uh-oh. What's wrong?
Well, there's a line
Yep.
over there. You need to pen up.
Yep, that's the last thing. Part of the reason I like this one on a not exam, on a practice, is that then I can do Bob dot up over here, and then Bob dot down. And there we go. So, I'm going to keep going. This class doesn't end until 3:20, and there's still plenty of questions to go over. Okay, so next we have extra practice. I'm not going to do this one, but now that you understand how to do the first one, you should be able to try this on your own. This will make a good leftover practice problem for prepping for the exam. This one, there's an equivalent on the exam, but it's very worthwhile to go through to understand the next question. So foo, we have three things. Foo, bar, and baz. These are what we call metasyntactic variable names. If you are from the military background, right, maybe in the National Guard or you're here on your GI Bill, you may be familiar with the term FUBAR. Well, that's where we get FUBAR. That's where we get our acronyms from in the U.S. Other countries have other metasyntactic variable names.
Yeah, FUBAR is spelled wrong.
It should be a U, shouldn't it?
It's fucked up beyond all recognition.
Yep, fouled up beyond all recognition. Exactly what you said. This class is rated PG-13. We get only one F-bomb. I'm glad you didn't use it. So the main thing here is that so that's where foo and bar and baz come from. Python likes to also use spam as a metasyntactic variable a lot, and eggs from the Monty Python skit Spam and Eggs, which if you've never seen is hilarious. All right, so foo prints the word foo. Bar calls foo, prints bar, and calls baz. Def is baz. Baz prints baz and calls foo. So what is the output of this following program? Well, again, don't try to solve it in your head. What we're going to do is we are going to take this and we are going to write stuff down as we go through it. Your pencil is your greatest tool, and I mean that both in the sense of when you do programming and not programming. One of my best friends, he works at Google. He makes like absurd amounts of money, like $500,000 or something. Okay? And his thing was he would always write down his programs on paper before he started programming, or his ideas on paper, because it's easy to make sure that, because it's just an easier way to do it, to know the direction you want to go before you actually do this. Okay? It's much easier to add notes or draw things on paper too. So paper's underrated as a tool for a programmer. Okay, so over here we have foo, bar, baz. So, so what we do here is we have called foo first. Foo is very simple, it just prints foo. Bar calls foo, which prints foo. It prints out bar, and it calls baz. Baz is very simple. It prints out baz and calls foo. Okay? The last one is baz, which we just did, so that is, again, printing out baz and calling foo, which just prints out foo. Now, the fun part, quote unquote, is of this question is, what if we change baz to call foo and then call bar? Okay, long story short, there's two answers I would accept on the exam, which is that it's an infinite loop, or what actually happens was it's a Stack Overflow error. Okay, because essentially that gets into how function calls can only go so deep before the computer runs out of memory allotted for the program. So what would happen is that you would have foo, baz would call foo and then bar calls baz, which would call foo and bar, and then bar would call baz, and baz would call bar, and bar would call baz, and baz would call bar, and it would just go on forever. There's no stopping point. Okay? You can accidentally write programs that do something called an infinite loop. It happens. Okay. Let's see. Yep, and that's fine to skip this one, but okay, good. This one I don't want to skip because I know for a fact this one, these next two questions, 17 and 18, notice I put the warning that these are trick questions on there, okay? Okay, these are trick questions. I can assure you, and especially if you're an IC or computer science major or got to take the next class, which is 1068, listen up. I know Professor Fiore loves to ask questions like this because these are important to understand. Okay? What is the following output of this code? Confundus, YXZ. And then I have print ZYX and XYZ, confundus ZXY. Yeah, no, so notice that I've just arranged Z, X, and Y however which way I wanted. Why? To confuse you, of course. So when the professor presents you with some utter nonsense like this, use your pencil and paper and change the code. Or specifically, change the variable names, okay? So that's what I'm going to do. Rather than, because remember, and why can we do that? Well, remember, anytime we come across this in the wild, where we have the same variable used inside and outside, remember that these variable names have nothing to do with each other. They're just labels. The variables on the inside of a function and the variables on the outside of a function, they're completely different variable names. This x is different than that x. So let's go ahead and just rename them. So that was a y I just scratched out, right? So I'm going to replace all the y's with a. A, and A. X is going to be B. Okay. And X, B. Now, why is this important? Because I'm trying to emphasize something. First and foremost, these function calls, when we pass values into a function, they are positional. And doing this is going to help you remind you that these are positional. Okay. So we have x is equal to 6, y is equal to a, z is equal to 4. Confundus zxy. Now the tricky thing here a lot of times is students will be like, okay, so I'm going to go and match the z to the z, the x to the x, the y to the y. No, they're different variables. They're different variables. If we do it any other way, it's too much mental load on us poor programmers. Okay, so instead, and this is also why part of the reason you want to use good variable names instead of just x, y, and z. So here, 6, 8, 4. So z is 4, 4, x is 6, and y is 8. So 4, 6, 8. How convenient, they're in numerical order. Okay, now we pass those in order up here. 4, 6, 8. So first we have b is equal to b plus 1. Sorry, b is equal to b plus 1, right? b plus equals 1. That becomes 7. A is equal to a minus b plus c. Okay? A is equal to a minus b plus c. So a is equal to 4 minus 7 plus 8. Right? 4 minus 7 is negative 3 plus 8 is 5. Right? And then it wants us to print CBA. So I think that's 875. I feel like I'm missing, I did math wrong here somewhere because it should be 876. All right, give me one more minute, please. This one's important, okay? The output of this following code. This one is a trick question. The answer to this one is 17, 8, and 2. Okay, which is just the numbers over here. Over here we have a bunch of variable operations, including squaring and doing modulo and nonsense math. Remember, These variables on over here, as I just mentioned, are completely different variables over here. Relabel them A, B, C again, and it suddenly makes sense because I've just changed the variables over here. Of course it's not going to change the variables over here. Why? This one emphasizes that the things you pass in are positional. The second, this part says, anything I pass into a function is a copy of that value. Everything in all programming languages, pretty much modern programming languages, work the same way, which is pass by copy, with a hefty asterisk where objects are involved, but everything is pass by copy, okay? Where we copy the value from outside the function to inside the function. That way, we don't modify it. The hefty asterisk comes later because that talks about memory addresses, but that's all we need. We don't need to go over this one because there isn't one on this exam, but it is worthwhile for you to do, okay? Actually, yes. I would do this one. There's something, because there's a question that says write a for loop that prints out all numbers from, and then I give you something to do that, okay? So it is worthwhile to do that one, okay? So with that, good luck on the exam. If you know that you're going to be missing an exam like right now, please let me know and we can discuss that and come up with that.